Hello friends, today we are gathered here for the subject microprocessor unit 3 descriptive tables. Okay, global descriptor table, local descriptor table and a interrupt descriptor table. A descriptor tables. The descriptor tables in which the segment descriptors are grouped and placed one after another in a continuous memory location. This group arrangement is known as a descriptor table. The maximum limit for the length of the descriptor table is 64 kilobytes, and each descriptor table takes 6 bytes to store the information of a particular segment. So a descriptor table can have as many as 892 descriptors, that is 2 raised to power 13 descriptors. The upper 13 bit of a selectors are used as an index into the another descriptor. There are three types of the descriptor tables. Global descriptor table, which is known as the GDT. This general purpose table of the description. Global descriptor table is also known as a general purpose descriptor table, can be used by all the programs to reference the program segments of the memory. GDT can have any type of the segment descriptor except for descriptors which are used for serving the interrupts. Interrupt descriptor table IDT. It holds the segment descriptors that define interrupts or exception handling routines. The IDT is a replacement for an interrupt vector table used in 8052, 8085 system. The local descriptor table, they are set up in a system for an individual task or closely related group tasks. The selectors playing the more important role here. The selector, the portion of a logical address, identifies the descriptor by specifying a descriptor table and indexing a descriptor within the table. The selector may be visible to applications programs as a field within a pointer variable, but the values of the selectors are usually assigned by linker or a link table. Here we'll see the format of the selector, which is a 15-bit, in which three fields are there: RPL, which is a request privilege level; TI, which is a table indicator; and an index field, which is of the 3 to 15-bit. The index field selects one of the 8192 descriptors in a descriptor table. The processor simply multiplies this index value by 8 and adds the result to the base address of the descriptor table in order to access the description segment descriptor in a table. A table indicator specifies to which a descriptor table the selector refers. A 0 indicates the GDT and a 1 indicates the current LDT. That is, a 0 indicates the global descriptor table, whereas a 1 indicate a table indicator 1 indicates the current local descriptor table. A request privilege levels used by protection mechanism. Now we'll see the Gdtr, global descriptor table register. Gdtr is a 48-bit register located inside the 8036DX. The lower 2 bytes of this register specifies the limit for the GDT. The value of the limit is a 1 less than the actual size of the table. For example, if the limit is 0003FFH, then the table is of the 10323 plus 1, that is a 1024 bytes in the length, that is 00FF is equal to 12316. Says a limit field is a 16-bit long and the GDT can grow up to the 65,536 bytes long. The upper 4 bytes of the GDT specifies a 32-bit linear address of the base of a global descriptor table. So here we'll find a IDTR, a length, IDTR Format of the IDTR: base, a limit which is from 0 to 15 bit, that is a 16-bit limit is there, and a 32-bit base address is there. A 32-bit base address which is 0 to 23, and a 24 to 31 bit which is shown here, which access this limit which is shown in physical memory locations interrupt descriptor table as shown in a figure. Like a global descriptor table register, interrupt descriptor table register holds the 16-bit limit and a 32-bit linear address of the base of an interrupt descriptor table. The interrupt descriptor table registers are used to define an interrupt descriptor table in the 8036DX physical memory address space. Like Gdtr, the IDTR is also a 48-bit in length with a lower 2 bytes space defines limits and upper 4 byte defines a base address. Since limit field is a 2 bytes, the IDT can also be up to the 65,536 bytes long. But 8036DX only supports up to the 256 interrupts or exceptions. Therefore, the size of the IDT should not be set to support more than a 255 to 56 interrupts. The LDTR, the figure as shown in a figure, the limit and a base. Okay, so this limit and a LDTR selector is there, which the LDT descriptor is there, descriptor tables are there. Okay, so which are used to access the tables. Unlike the GTTR and IDTR, the LDTR is a 16-bit register. It does not specify any limit. Whereas IDTR and GTTR having the limit of the 15 bits, 16-bit, whereas the LDTR doesn't having any limit or a base address for the segment, but it specifies the address of the LDT descriptor stored in a global descriptor table. LDTR holds a selector that points to an LDT descriptor in a GDT. Whenever a selector is loaded into the LDTR, the corresponding descriptor is located in the global descriptor table. The content of this descriptor defines the local descriptor table. The 32-bit base value defines starting point of the table in the 8036DX physical memory address space and a 16-bit limit specified size of the table. So LDTR, the GDT can contains many LDT descriptors. As we see in the previous figure, the GDT contains the many LDT descriptors. To put a particular LDT in a service, it is necessary to load the LDTR with a corresponding selector. For loading the value in a GDTR, IDTR and LDTR registers, 80386 provides LGDT, LLDT and LIDT instructions. These instructions are used to load the values of the GDTR, IDTR and LDTR. It also provides the SGDT, SLDT and SIDT instructions. Besides the LGDT, LLDT and LIDT, 386 provides the SGDT, SLDT and SIDT instructions to load the values in a GDTR, IDTR and LDTR. These 48-bit instructions copy the contents of the descriptor table register into the 6 byte of the memory pointed by the destination operands. These tables are manipulated by the operating systems. Thus, the instructions used for loading the descriptor tables are privileged instructions. Thank you for watching the video.